we make it happen in NHHID. And this was now testimony is 3 more biomedical devices hubs. Not only product development hubs themselves have come up. PGI Chandigarh, Mangalore in Manipal in Mangalore, and Maulana Azad in New Delhi. So this itself shows that this program, the whole idea is every state will have one hub, and we are looking for it as a dream come true. And one satellite hub to NHHID we have started in Baghdad University. Several satellite hubs will now come, and within next 10 years there will be transformative effect uh, in the country. Thank you very much.
Thank you, sir. Thank you for your elaborate presentation on the NIHHID. And we are very sure that the kind of enthusiasm and the hard work, the kind of team you have and your leadership will definitely take us in further heights. Thank you very much, sir. Thank you.
Thank you. Thank you very much.
Now it is my pleasure and privilege to invite another eminent personality among us, Dr. K.J. Sriram, Director of Central Leather Research Institute, Chennai. Dr. Sriram is a fellow of Royal Society of Chemistry, UK, and Society of Leather Technologies and Chemistry, UK. And prior to being the director of institute, he has contributed for the development of test methods for leather and allied products and achieving ISO standards. Dr. Sriram has made important contributions in the green chemistry of chromium that has opened up new paths for better industrial management of this metal in the global level. These contributions have led to his becoming the first researcher with a degree in leather technology from Anna University to receive the CSIR Young Scientist Award in the year 2004. Dr. Sriram has also contributed immensely to the development of environmentally benign and cool pigments from rare earth metal ions as a replacement to the pigments based on toxic metal ions such as chromium, lead, mercury, etc. Also been credited with commercially successful technologies for avoidance of formaldehyde in tanning agents. During the last 5 years, in order to exploit the advantage of nanoscience for developing materials with unique applications, Dr. Sriram has developed a range of functionalized metals and metal oxide nanoparticles with potential applications in cross-linking of proteins, a work which has led is being recognized by International Union of Leather Technologists and Chemists Society with the International Union of Research Award. Dr. Sriram has 96 papers in national and international journals, 1,666 citations with a Hertz index of 21. He has 19 patents to his credit with several technology transfers and consultancy activities. With such an eminent personality among us, it is our pleasure and privilege to have you, sir. Please, your address, please.
Thank you very much, Professor Ramsamy, and thanks for this opportunity. I would like to talk about what we do in CLRI as a part of our technology translation. Of course, the name CLRI in the last 75 years has remained synonymous with leather. And I would like to point out here that this institute, right from its word go, has been having a good industry institute policy connect, and therefore has been able to bring out science research innovation system for high trade benefits to India. This is where we start off. Just to give a small background to people who are not aware of the progress of the leather industry, in 1947, the predominant export from this particular industry was a trade material, the raw hides and skins, at that time valued about 30 lakh rupees. Since then to today, the industry is one of the best exporters of leather and leather products to the value of more than 48,000 crore rupees. And in this process, the Central Leather Research Institute, have been partnering them in progressing the leather industry from a raw hides and skins trader to one of the best quality leather and footwear manufacturers. So now, having said this, let me take you as to how we do this. By 1964, this institute established what we call as a leather research industry get-together. At that point of time, in 64, we called it as the Tanners Get-Together. It was a commitment of everyone involved, whether it be the students of the Anna University, then the University of Madras, who were studying BTech program in leather technology, or whether it be the researchers in CLRI or the industry themselves. All of us were committed to come together on a platform so as to ensure that there were high trade benefits to India from leather. In this journey, the institute was just a catalyst. We ensured that the right technology, the technologist, and the technology consumer came together to the benefit of the country. And the success of this program has been the presence of the industry. Whenever the lyric dates, usually it's a fixed dates in the calendar year. Whenever these dates are announced, the industry makes sure of its participation in the program. So the journey of the leather research industry get together, as I said, it was from the visionary Dr. Y. Naiduma, who conceived it as a tanners get together in the very campus of CLRI itself in 1964. The TGT transformed into a get together of the research and industry in 86. And since 2022, it has moved from a get together mindset into a conclave mindset of research, industry, and government. The essential feature of bringing in the government into the platform is that wherever there is a requirement of a policy support, it will be provided, and there will be a policy support to imbibe technology and modernization into the industry. This entire conclave, which runs from any 1 day to 3 days, is actually action focused, and both the stake and shareholders of the sector are involved in it. So how do we bring about high trade benefits? Whenever we talk about technology, we need to give to the industry a basket of technologies. And here we give them the options of choosing from existing. So if you take current trend in 2022-23, we are talking about technologies which have a low ecological footprint, carbon footprint, energy footprint, technologies which can help in recycling and biodegradability, technologies that can bring in social sustainability and economic sustainability. Then we are also looking forward to supporting the industry with materials which are 5 to 10 years ahead of schedule. That's what the research is currently, what we call as the upcoming technologies. Leather-like materials, recycled materials, vegan materials, and so on and so forth. Of course, we also perform the developing task of working together with the industry. Industry best knows the consumer demands. So matching the properties of the expectations of the consumer based on customized solutions for the industry is one of the successes of this institute. Our approach to technology delivery is that a one size fits all is not going to work. We look forward to customizing and personalizing R&D to the requirements of the industry who is coming forward to us. This would be product-wise, sector-wise, and even consumer-wise. So this is where the CLRI works on. There are two aspects to technology translation which we always look at. One is the technology readiness level. I need not elaborate on the technology readiness levels, but in the institute, we have a concept that no technology will go to the industry unless otherwise the technology has been proven on an industrial environment, but at scales slightly one notch lower than the industrial scales. So essentially, after the pilot scale trials are over in CLRI, we go to some friendly industries, take up the product or the process technology there, and see what are the issues that we come up in case we were to take it to commercial levels. Only after that success is done with, we go for commercialization of the technology. This brings in a lot of confidence in the industry on us. The advantage that CLRI has in this entire process is that 60% of the manpower the technology manpower in the leather industry in the country is our alumni. So we have people who readily welcome us, offer their industrial scale facilities to us to do the trial runs in their places. During the working out of the technology preparedness costing, that is a project cost for R&D, we ensure that we put in enough money to even buy the entire lot of 1 ton or 2 ton materials, so that the industry does not have to sacrifice on that aspects. So this is where we talk about technology translation, and this is where our success rate comes up as well. This, if I were to put it in the words of Dr. Naiduma, one of the best scientists that this institute has had, he was considered as a social scientist and turns 100 this next month. He tells us that it is not enough to conduct research and to develop the know-how. It is necessary to sell research. An integrated information service or a license network should be set up to permit free flow of information from industry to the institute. So here, what this institute does is that we conduct meetings or brainstorming sessions with the industry at their places, at their clusters, to understand what is the industrial need and then tune the R&D according to the industrial need. An unhampered flow of research findings and services benefits the institute to industry, and this follows continuously. The best way, according to Dr. Naiduma, which we follow in principle today, is to sell research by taking it in the sense that to the first seller or the first buyer of our technology, we say, you take the profit and we take the losses. So it's not the cost of the technology what matters. It is the goodwill that we earn from our first set of buyers. And then after, the technology propagates by itself. One of the classical examples that we have done in recent times is a technology, what we call as the waterless chrome tanning technology. In this, the entire process of tanning, which used to take about 12 to 13 liters of water per kilogram of the hide or skin, has been made into zero water consumption. Industry was skeptic. How can this be done? It will spoil the entire material, this and that. We took this technology at zero cost, and in some cases at a license fee of just 10,000 rupees. Today, we have given this technology license to over 150 tanners in India. Having seen the success of this technology in India, we were able to get people coming for this technology from various other parts of the world. And that's where our profit or return on investments were coming in. So this is how the institute talks about technology translation in the true sense. Of course, whenever we talk about technology, one thing which we have to ensure is that the industry also has the right manpower to revive that technology and also look at the success of the technology. So providing the skilled manpower, professional management, customized manpower if it is required, and benchmarking our technology in case it needs to be benchmarked, and normalizing it to the conventional technologies is the mandate of ours. So we don't just stop with the technology. We also provide the technology related manpower and also the benchmarking and normalization services that the industry might require. In this process, what we have done is to adjust some of our training curriculum also to the technology requirements. For instance, we package various process technologies and also parallelly conduct training programs to the industry on various concepts like raw materials, relevant products, sourcing, sample product development, quality control, automation, etc., which then helps us to sell the technology to them. So tune the manpower first, then take the high-end technologies to them, and then get their goodwill and move forward is the success rate mantra that this institute has been looking forward with. Before I wind up, I just would like to give you two examples of what we had done in the last 5 years. The first rewarding experience is an entrepreneur. He was a master's of technology in leather technology from the Anna University through this institute. He started a company by himself in the 80s to develop leather finishing chemicals in India. That was the first self-reliant company who was making leather finishes in India itself. His first product was his own Master of Technology dissertation work, and that we helped him and become an entrepreneur. Years later, now he has come back and taken a license for a tanning agent without formaldehyde, the first of its kind in the world. And here, he was able to break even point of investment in the first year itself. He has targeted gaining a market share of 20 to 30% in the entire gamut of synthetic tanning agent chemistries, which is predominantly an external import driven or foreign company investment into India driven activity. He has won several awards for this technology propagation. Another guy is a new one, a young guy who put up a company in the name of Amati Green Private Limited in Mumbai, wanted to develop leather-like materials from mango waste. He identified the investors, he identified benchmark products, and we worked with him to develop high quality products much better than the benchmark products. And he proposes to launch this product by December 2022. He also has promised us that the entire CSR, the corporate social responsibility grants that he would have, he will put it into the scholarship for research scholars. So we sell the technology at a lower price to them, gain their goodwill, keep the industry with us. CLRI has had a good success rate in keeping the industry with us forever. And with this, as our way forward, I thank you for this opportunity given to me. And I hope our mechanisms is something which other people can also look at and have a better institute or academy institute industry partnerships. Thank you very much.
Thank you, Dr. Sriram sir. Whenever we are bringing students to that institute, their hospitality, their explanation to the students and the collaboration is laurel to our council as well as our Atmanirbharatha Bharat. He is always motivating young students to take up technology further as it. Thank you, sir. Thank you very much.
Thank you very much, sir.
Dr. Ramsam next. Dr. Ramaswamy.
Yes, sir. Yes, sir. Sorry for the trouble. There was some network problem. Thank you very much, sir, for your kind presence today and beautiful explanation about the activities and the transfer of technologies done by CLRI for the benefit of leather industries as a whole, not only for Tamil Nadu, but for the entire nation. With the support of CLRI, I am sure that the leather industry will grow and it will reap a lot of economic benefits for our country and make our country self-reliant. Thank you, sir. Now it is my pleasure and privilege to introduce another eminent speaker, Dr. Shaktivel, Joint Director and General Manager from the MSME Department, particularly from Trade and Investment Promotion Bureau of our state. Dr. Shaktivel is a Joint Director of MSME Department, General Manager, MSME Trade and Investment Promotion Bureau, Regional Joint Director in Chennai District Industry Center, and Joint Director Engineering for Chemical Testing and Analytical Laboratory, General Manager District Industry Center Kanjipuram, and General Manager District Industry Center Tiruvallur. And he has been also doing a lot of service in the other capacities, more than 2 to 3 decades of service in the particular field. It is our pleasure to have you, sir, here, and yes, we welcome you to show the importance and the role played by the Trade and the Investment Promotion Bureau for the industry sector. Thank you, sir.
Good morning to all. I would like to elaborate the schemes and the incentives which are available for MSMEs in Tamil Nadu, as well as the other people. We are also would like to invite the other state people also to come and invest in Tamil Nadu. That's why that is our motto. I'm working as a general manager. Let me brief it through my PPT. Please, sir, Ramasamy sir, please run through the PPT.
Yes, sir. Yes, sir. The first set of slides where it is about the district industry center. You can show now.
Yeah.
DIC, district industry center slides.
Yes.
Gomati?
Control, sir.
Okay, okay.
Other PPT, ma. Other PPT. Commissionerate. This one. So DIC is not district industry centers. We have all in all districts, 38 districts. We have district industry center headed by the general manager to cater the needs of the for MSMEs in all respects. Next slide. This is the commissionerate is the head office wherein I am working here under the separate society which is called MTIP, MSME Trade and Investment Promotion Bureau. The Commissioner of Industries and Director of Industries and Commerce is the total head of the department to all these district industry centers. These are the functions I want to deliberate. Number one, this is this compromise I told you, commissionerate, and this MSME department in Tamil Nadu, two departments in respect of the industries department, industries. It is coming under the MSME, micro, small and medium enterprises department and large industries department. So that we are coming under MSME for the development. So this consists of the commissionerate wherein I told you I am working here, and Tamil Nadu State Industries Development Company, TIDCO. They will give the developed plots and sheds for the MSMEs, and TANSI is a manufacturing unit, and EDIA, Entrepreneurship Development and Innovation Institute. There it is given provide training and MSME Trade and Investment Promotion Bureau, wherein I am the general manager. Next slide, please. So these are these days working on this views. That's employment generation and motivating, guiding the entrepreneurs, rendering escort service to set up enterprise. Likewise, even up to is going to export guidance in South Southern and industrial cooperative societies South Southern. Next slide. Next slide. So this is the basic definition. The previous slide, Amma. Please come to the previous slide. Yeah, this is the basic definition for the MSMEs. MSMEs means micro, small, medium enterprises. So this is a micro means this is the definition given by Government of India. That micro is those units having 1 crore. That was the previous, not the investment in machinery is 1 crore now, and the turnover is 5 crores. And for small enterprises, the value of the machinery is 10 crores and 50 crores turnover. And for medium enterprises, it is machinery investment is in 50 crores and 250 crores turnover. Next slide. So this is the business Tamil Nadu Business Facilitation Act and rule. This has been enacted to make to achieve the ease of doing business in Tamil Nadu. Therein, to get the MSMEs have to get various types of clearances from various statutory departments like fire, health, factories, and pollution control board, etc. About there are about 55 licenses are there. So these MSMEs have to go there and getting it. It's a difficult thing. Thereby, it's a single. For that only as a separate Business Facilitation Act was enacted, and under that, separate single window portal is now working, functioning, wherein any MSME can apply directly. See, there is the pre-establishment clearance and pre-operative clearances and renewals of auto renewals and all these type of are to make the ease of doing business in that environment friendly thing. Then it was enacted. It is under implementation. We are doing that also. Next slide, ma'am. So this is this single window portal I told you, no. It consists of these things. Single window point for accepting, and it will distribute the application to the right department, and it will be all these functions are controlled by each and every district. There is a district collector is the single window clearance committee meeting chairman. Each and every month he will view the applications. It is visible to a collector as well as the state level committee, wherein our commissioner is the convener, and also a separate board is there under our MSME minister. So that under this Business Facilitation Act, for every clearance there is a time limit was given. As per that, it has to be given. Once he applied, that the clock will start starting, and the concerned department has to raise the query through that portal only. Then whenever the applicant gives the reply, then it will start like that. So that it will be each and every month reviewed by the district collector in the districts, as well as once in 2 months in and as and when required by the Commissioner of Industries and the state level. Next slide, please. So these are the single window portal. All these departments, what I told you about 55 clearances. These are the departments which are coming under that folder. Next one. Next slide. Then apart from that, our DAs are implementing these kind of self-employment schemes. That is the number one is the new entrepreneur come enterprise development scheme, which is a very novel scheme. That is for project cost up to 500 lakhs. A person wants to, entrepreneur wants to start a manufacturing or service sector enterprises, he can approach the concerned DIC in the state, and wherein all application will be hand-holding for filing the application will be given, and so the same will be forwarded and recommended to the concerned bank branch or Tamil Nadu Industrial Investment Corporation. Therein to get the sanction, we will our GMC will be monitoring the application, will going approaching the banks as well as that, and after getting the sanctions from the bank, and after getting the first disbursement of at least 25% of the loan, subsidy of 25%, wherein this scheme subsidy of 25% to the maximum of 75 lakhs will be dispersed. Further 50% will be dispersed on the first initial disbursement of the loan itself. Therein the assets can be created. So then the second 25% and third installment 25% will be dispersed later on creation of assets and starting of commencement of the unit. And in this scheme, not only manufacturing enterprises, the enterprises, service enterprises like small hospitals, dental clinics, and restaurants, and whatever kind of servicing of car service station like that, servicing category also will get subsidy. In the scheme only, you will get the subsidy to the maximum of 75 lakhs. Also in the scheme, we have our GMC will be dispersing about 3% interest subvention subsidy. For the loan, no, the entrepreneurs getting the loan from the banks, 3% of the interest loan by them, that will be reimbursed once in 3 months. This is the first scheme I have elaborated. The next one is the Unemployed Youth Employment Generation Program, that is called UIGP. That is the schemes applicable for the project cost, service and manufacturing and service, as well as trading also here. Up to the project cost is maximum of 15 lakhs. So wherein subsidy up to 20% is also there. And the third scheme is the Prime Minister's Employment Generation Program. It's a scheme called, it's the Government of India scheme, wherein the project cost up to 25 lakhs. Projects will be started, and now it has been increased to 50 lakhs also. We are expecting the GOs also. These are the details what I told you. The basic details of the eligibility of the scheme, need scheme is given in this slide. Next slide, please. This is the basic all details of the other two schemes also. Please rush to the next slide, ma'am. So apart from these are these three schemes I have told you that's applicable for the new entrepreneurs who are unemployed, educated youth who will want to become as an entrepreneur. These are the schemes, incentive schemes for the MSMEs already existing, as well as started by other people also who are not coming under eligible under the three schemes. See, for these schemes, the capital subsidy and special capital subsidy on the cost of 20% on the cost of the machineries up to 150 lakhs will be dispersed. So here all types of additional capital subsidies. This is select category and cleaner environment, etc. That is additional subsidy of for a micro enterprises up to 10% on plant and machinery value. So the maximum of 5 lakhs will be given, and additional subsidy for the select category, that is 5% of plant and machinery value of 5 lakhs, and additional subsidy for promotion of cleaner and select category means women, SC, ST, and all special type of category which is specified by the government, and additional subsidy for promoting cleaner and environment friendly technologies. That is also available for 20% on the cost of plant and machinery for up to maximum of 10 lakhs. And another kind of additional subsidy is scaling up from micro to small and small to medium also. These are all these things are applicable to the units which are established in some declared government backward blocks as about 345 blocks are declared in by government to promote the industries, MSMEs in that area. And there will kind of another subsidy, payroll subsidy for keeping more than 25 employees. The payroll, their EPF contribution will be shared for 3 years, as well as the low tension power tariff subsidy is for giving low tension power connection they got up to 450 HP. They will be given 3 years power subsidy for 3 years. That is 20% of the power consumption what they have paid the amount to the EP, that will be dispersed, reimbursed by the government. And another kind of generator subsidy, now it is on hold, hold, and the interest subvention for technology upgradation, modernization, CGTMSC. Normally, under top schemes, banks will be dispersing some loans. Please stay on the yes. For technology upgradation, under top schemes, banks are dispersing loans, and as well as on the CGTMSC means credit guarantee scheme for micro and small enterprises scheme. That is the scheme for that is without collateral. Normally, whenever the people, MSMEs or unemployed youth goes to and approach the banks, financial institution for loan, they will have collateral security. So to support the scheme, whoever are not having the collateral, this CGTMSC scheme is the Government of India. A separate trust is there. That trust will give the guarantee, credit guarantee to the bank on behalf of the entrepreneur up to 2 crores project cost. So on that, such a kind of loans which are dispersed to the entrepreneurs, this interest subvention and will be given up to 5% throughout the loan period. And the next one is the incentive for promotion of energy audit and energy consumption of energy. So this is accredited energy auditors are available, are accredited by Energy Efficiency Bureau of Government of Tamil Nadu are available. By using them, energy audit may be taken by the MSME to find out what are the issues there. And for that, charges, energy audit charges will be also reimbursed by state government. And after that energy audit report has come, there must be some recommendation by the committee, that auditor, that for implementing that as a subsidy schemes also there. This is mainly for promotion of energy conservation and incentive scheme for quality certification for ISO and all other upgraded certifications, quality certifications like SZTD, like that. That amount incurred will be reimbursed by the government, and reimbursement of stamp duty and registration charges. For example, a unit is going to purchase a land in a backward block for starting of MSME unit. That registration cost as well as stamp duty incurred by them will be reimbursement by DICs, and subsidy of asset creation of IP, intellectual property also for the expenditure incurred, that will be also reimbursed. And scheme for fundraising through SME exchange with the National Stock Exchange as well as and Mumbai Stock Exchange. What are the costs for uploading, and the IPO charges will be reimbursed by the government. Next slide. Then this is a special capital subsidy for purpose. I told that other backward 345 backward blocks, that package of incentives were given earlier to slides I told. So, some of the about 20 type of products were selected under the thrust sector, and government is giving special capital subsidy for the thrust sectors, which all these MSME units can be established throughout Tamil Nadu at anywhere. That are illustrated here: electrical and electronic industries, leather industries, and auto component, drugs and pharmaceuticals, solar energy, gold and diamond jewelry, sports goods, cosmetic, building materials. These are to encourage these kind of activities. So next slide. 24 activities. Then back ended. Yeah. Next slide. This I told you already. This CGTMSC up to 20 lakhs amount. 20 lakhs will be given for the loan of 200 lakhs. The technology upgradation fund. 25 lakhs for that interest subsidy itself. Interest only. So it will be accumulated like that. Next one. Tender subsidy is now, it is not kept under hold by government. We go to the next slide. Next slide. Payroll subsidy, that also I earlier told. These are the details, basic details of the thing. Please. Next. These also I have explained. Everything are available in our website, wherein you can see. Then next slide. This I already explained. Fundraising also I explained. Next one. Next slide, ma. Quality certification. The basic who are eligible, how to apply, and all of these details. This skill training also to facilitate the. This is the skill training. Next one. Where the skill training will be for MSMEs who are taking their employees as apprentices, and for 6 months an amount of 2,000 rupees will be reimbursed for a candidate. About 12,000 will be reimbursed. That scheme is the skill training scheme. Now I am coming to our specific activities of MTIP. This our motto is accelerating the growth of MSME. Is our motto. Next slide. So this is our Industries Commissioner is the Managing Director, Madam Siji Thomas Vaidyan, and our Additional Commissioner, Mr. Utsav IAS, that's the executive director, and I am the general manager. And I will explain in the government details. Next slide. Can you enlarge this? See, this vertical that we are mainly we are working on trade and promotion and facilitation. Then facilitation on MSME financing and investment promotion of facilitation and knowledge dissemination. These are the four verticals we are working on that. We have conducted so many. Next slide. No? Can you come to the next slide? These are the services. No? Can you zoom it? Can you zoom the thing? Yeah. When we started. Branding services. See this. See, if an MSME wants to create their own website and catalog, brochures and pamphlets, presentation, these things can be also handholded by HIP. Next, assisting the MSMEs to increase the revenue in way of linking them to buyers through buyer-seller meets and linking them to for export incubators and export B2B platforms also. And the financial services also we are giving. Can you zoom down? So we have already done. So in financing services, linkage to formal credit such as these are the new verticals we have taken. Tamil Nadu Credit Guarantee Scheme. Actually, I have explained in the previous PPT. The Credit Guarantee Fund CGT MSC scheme that is applicable. The guarantee will be given up to 70% of the loan only. Here for supporting them, Tamil Nadu government has taken this new scheme. It's going to be inaugurated by next month by our Honorable Chief Minister. That is called Tamil Nadu Credit Guarantee Scheme, wherein the 90% of the collateral, the balance 20% will be given by government of Tamil Nadu for the faster, promotion of MSMEs and also faster realization of payments through TREDS. TREDS is Trade Receivables and Discounting System. This is for bill discounting system. Already PSUs are onboarded on that. It's already existing scheme. We are in the process of making all Tamil Nadu PSUs as well as the government of Tamil Nadu departments about 97 departments to onboard to come in this portal, wherein whenever the unit MSME supply any their products to the to these departments as well as the renders and services, the bill will be can be uploaded and immediately the payment will be dispersed by the platform holders like M1 Exchange and RXI, etc. And recovery of delayed payments through MSME Samadhan. This is the MSME Samadhan scheme is there by Government of India. Under that, facilitation councils are already formed in Tamil Nadu in 4 regions like Chennai, Trichy, Madurai, and Coimbatore, where in all the districts, MSMEs in districts, these regions supplies to any other large industries wherever in India. They can, if there are any problem in their payments, they can file their applications. They will be regularly taken under these councils, and this is a quasi-judicial forum. It will be heard. Both persons, the petitioner and respondent will be heard by the that council is and the judgment will be passed under the MSMED Act 2006. If the judgment is passed that has to make the payment, if not pay, he is failing the, the respondent who are not delayed, defaulted in the payment right time, in the right time, he has to pay the amount with 3 times interest with monthly rest also. If he wants to contest in the court, if he want to go, means he has to pay the 75% of the amount which is awarded by this council. That is the judgment. So it's a scheme. Under this scheme, Tamil Nadu is standing first, and our commissioner has received the award for that purpose or for that work also. And we are assisting in getting clearance. I told you that form, how to fill up the forms in single window portal, and how to do the documents also. And we are following up with the line departments in time, and as I already told that this 2 committee meetings will be conducted. So this kind of annual services are given by our department. Next slide, please. Next slide, please. So the Udyam registration is the basic registration for MSMEs that is given by the databases maintained by Government of India. That this is no cost it was made, and for existing enterprises, that EM Part 2 previously is there, now it is not there. Only Udyam portal for new enterprises who want to establish, they are not necessary to file the mention the date of commencement of production, and this is the Udyam registration type thing. We are on the process of collecting database also, MSME database. Next slide, please. These are the various benefits of the MSMEs getting they guaranteed they have created buyer seller meets for sector and product also. Attending exhibition in MT for attending exhibitions, expos wherein in Tamil Nadu and India, and even in foreign countries, international hubs. Under our new policy, the final year students also who are willing to go to the to visit the expo halls, expos, that can be also reimbursed, and availing credit card schemes. I trust, and I already told, and support and follow-up of single window application. I already explained. Onboarding onto e-commerce platform, Jump, government e-marketing place. This marketing assistance kind of thing. That also how to onboard. We are giving service, and subsidies are already explained. And the recent thing is ONDC. Open network for digital companies. We have conducted here our awareness program also in our Situ building, and updates and communication of MSME department on new activities also. Whatever is happening in the department we are doing, and MSME awards. These kinds of MSME awards we have already are giving. State level for best agro-based industry and best woman entrepreneur award, and award for best entrepreneur in the state, and state level for best quality at exports, and district level best entrepreneur, and state level for best performing banks also. So since the bankers are the vital persons to support MSMEs, that kind of this award is also introduced. Single window portal I already deliberated. Next, come to the next one. Next slide, please. This Samadhan also I have already explained. Next. This is a credit guarantee scheme. The details are available in the portal also. Tamil Nadu credit card is going to be inaugurated by next month. Rates receivable discounting scheme. This is for earlier payment for that. So now this is the new thing, micro cluster development program. That is up to 7.5 crores of assistance grant will be given by state government for 90% share micro cluster people. I mean, in the cluster, they want to make some common facility centers for soft intervention as well as the hard intervention also. We have received some about 50 crores on that also. We have been working at Pollachi also for common warehouse. Normally, there's Pollachi people, the Kaya fiber and the Kaya pith blocks. They are facing the two rain severians and due to the two monsoon season. And the small players, small MSMEs don't have any storage facilities. For that thing, we have already been on the process of approving one cluster proposal, micro cluster for 10 crores at Pollachi, wherein a common warehouse is going to be established. This kind of clusters, we have an idea and aim of promoting around 500 micro clusters, where that all can be also utilized. Next slide. And these are the various sector desks are available in our MS and MTIP and country desk also. In the thing we have already executed MOUs with Indo-German Chamber of Commerce, and based on that we have conducted 3 buyer seller meter on the German industries, and we are we are already interacting with France handholding support to France companies also, and Indo-American Chamber of Commerce. We have conducted a virtual expo also, and for Thailand, the engagement with the Royal Thai Conference also we are working on it, and we have conducted one small buyer food virtual webinar on food sector with the Department of Economic Development with Dubai, and these are the events sponsored by our department. Normally, we are sponsoring the event. This food expo was during the August 2021 at Mumbai. We have sponsored at various foods. Acme 2021 also we have sponsored, and Gulf Food, and now it's going. Timudivakam Estate is also going. That also we have sponsored. Next slide. Next one. Then there's up. Previous slide, please. Previous. So next one. State level credit guarantee scheme. This one is a new thing which will be very useful, and onboarding PSUs and on trade receivables system is a new one, and data-driven credit trading system we are developing to generate credit scores also, and we are in the process of doing creation of MSME database. Apart from that, we have another wing of MSME department, TN Startup, and in Tamil Nadu Startup and Innovation Mission, wherein the startups seed capital up to 10 lakhs will be given, and for promotion of prototype and other things also, and matching grants is also under they are working. So from the conceiving of idea and to market, enter marketing the product, and we are the MSME department is working. We are handholding the MSMEs and to develop them and handholding in all respects. So these are the things I request all the people. We can also want to point out one thing. The Government of India is also working on to reduce the import dependency. For him, I have attended a webinar before 1 month. So, sir, Dr. Shankar sir has initially told about that. For that also, we may have an internal discussion, and we can also for a technology transfer and R&D other things also we can work out, and we are ready to have a discussion on that. By this, I am closing my speech. Thank you very much.
Thank you, sir. Thank you very much for your elaborate address on the services and schemes offered by Government of Tamil Nadu. for the betterment of industry sector, particularly MSME. Thank you very much. Now it is my pleasure and privilege to invite another speaker, an eminent scientist, Dr. N. Anandavalli, Director, Structural Engineering Research Center, ASAR Madras. She has a research interest in blast response behavior of structures, computational methods, sustainable materials, and multi-scale modeling of composite materials. Recipient of Sir Arthur Cotton Memorial Prize 2003, John C. Gammon Prize 2016 from Institution of Engineers, Dr. M. Ramaya Prize 2017 from CSIR, awarded Raman Research Fellowship 2014 to 15 to conduct research on investigations on behavior of concrete using mesoscale models at Department of Civil Engineering, Johns Hopkins University, USA. He has a US patent and Indian patent granted on laced composite system based on her work. He is a member of BAS committee and various other committees on structural engineering. He has mentored many graduate and postgraduate students on, from engineering colleges and universities and guided PhD doctoral work. In addition to her role as a director of CSIR SCRC, he is also the coordinating director for CSIR Madras Complex. He is containing 5 CSIR laboratories. He is leading civil infrastructure and engineering team of CSIR as the team director and functioning as Director of Engineering Coordination of CSIR. Such a illustrious background. We are very happy to have you, Madam, for this meeting. Thank you very much for participating. Please, it is over to you, Madam. Thank you.
Thank you for the nice introduction. Am I audible?
Yes, Madam, you are audible.
Yeah, and my slides are visible?
Visible, Madam.
Start, madam. Sharing. Start.
Yeah. Good morning to one and all present here. I'll be talking on what the CSIR SCRC has developed technologies for in respect of structural engineering. Normally, civil engineering, what kind of technology, whether we can develop, those things will be a question for many of them. And if you see civil engineering, it's not just, it's a way of life. Like it's not only that engineering, it's a way of life. In any walk of life, you will find the role of civil engineers. And this is my organization, Structural Engineering Research Center, and this is the charter. This slide shows the overview of our campus and also the charter under which we are working. Like we want to do on all aspects of structural engineering, like design, construction, including rehabilitation of structures, and also we provide design consultancy services, and also conduct specialized courses on structural engineering to familiarize the practicing engineers with the latest developments. And how we are achieving our goals is through the 3 things. One is capacity building or the knowledge development through our cutting edge research, and also through the new facility creation. And the second is the knowledge application. So where we'll be applying the knowledge gained through sponsored project and industry applications, and also consultancy services. And the third is the knowledge dissemination. Once we gain this knowledge, confidence, and other things, we would like to disseminate through our courses, workshops, seminars, and conferences. And also we take part in the skill development program. And what are the different thrust areas on which our organization is working on? 4 different thrust areas, which is much needed for this need of the hour. One is on the structural health monitoring and life extension, which is more important, like due to large growth in infrastructure, and also towards smart cities and transportation and innovate in India. These are some of the relevant government of India initiatives towards which we are working on this. The second is the disaster mitigation. So we require the resilient infrastructure for disaster risk reduction, and also the Sendai framework 2015 to 2030 towards this. and also smart cities and innovate in India. All these form part of this. And the third thrust area is on the advanced materials for sustainable structures, because the material, the civil construction material is depleting natural resources. So we have to see for other materials, alternate materials, and also evaluate their properties, which are in towards sustainability. And the fourth is on the multifunctional, which is a new dimension, like which different functional aspects we'll be looking into it. And we have got a number of 10 divisions which they concentrate on these four thrust areas. So I'll give a glimpse of what all the infrastructure we are having. One is on the advanced concrete testing and evaluation laboratory, where we evaluate properties of concrete, and also we have done number of projects for NTPC where we evaluate the concrete strength in place. And the second is on the advanced seismic research and evaluation laboratory, which is towards seismic qualification. We have got a unique facility where a 4 meter by 4 meter shake table is there, where you can place the models of the building and conduct a shake table test. And we also have a 2 by 2 smaller table. Both of them can act together in synchronous and asynchronous mode. And also we have got a pseudo dynamic test facilities. So, and the other one is on the advanced materials laboratories, where we develop new materials, characterize them, and then we also have different facilities like hydraulic control, servo hydraulic controlled UTM, and also we have got CTM machines, and these are facilities that help us to characterize the newly developed materials. And the structural health monitoring laboratory, where we develop wireless remote health monitoring schemes and damage diagnostic techniques, and also smart sensing technologies. These are much essential for monitoring the structural health of the structures. And another unique facility, which is called as fatigue and fracture laboratory, which is more towards like as we become tired, similarly the structures also become tired because of the repeated loads. And to understand this and how to overcome the effects of that, this particular laboratory is concentrating. And wind engineer laboratory, this is the largest boundary layer wind tunnel, and where the scaled models of the structures will be kept in this wind tunnel and will be subjected to various wind speeds, and we'll characterize them. And then some BIS code has got standard configurations, while we can do this experiments under this wind engineering laboratory and get these other configuration, complex configurations. And another unique facility which I should mention here is on tower testing at research station, which is opposite our Madras airport, where a full-scale tower of about 80-meter high can be tested. And this is mandatory that these towers have to be tested for transmission line towers. And also the transmission line towers, not only we serve for our country, but also for the international clients. And another three laboratories which I would like to tell is on the steel structures laboratory, where we work on the cold form steel under elevated temperature, and also a fuse link has been developed, which is towards seismic resistance building. And also special multifunctional laboratory, where we have a very good heavy duty test floor, and also we have got a theoretical background. And theoretical and computational mechanics laboratory, in this we have got facility on instrumented impact test facility and high performance computing. And particularly this laboratory concentrates on impact and blast loads, and also textile reinforced concrete. So if I come to the technologies, that is the topic of today's lecture. These are the existing technologies which I would like to highlight upon, which are towards Atmanirbharatha Bharat, emergency retrieval system for power lines, and prefabricated EPS panels, and GRC, we have got various products. And also towards makeshift hospitals and other needs, we have got a portable lightweight foldable module, and a toilet unit with precast thin segmental elements, water tank with using flowable cement mortar and eco-friendly geopolymer blocks. I'll be just touching upon what are the different features of these technologies. Emergency retrieval system for power lines. As we know, this transmission lines, they towers, uh, uh, transmission line towers, they carry the power throughout the country. Like they are the nerves of this power transmission. And because of natural calamity or man-made disaster, they may collapse. And this will cause interruption of power transmission, which needs some time to be restored, like several weeks to be restored. And this will create a huge loss to the country, either in terms of monetary as well as service to the customers. So normally we'll have a emergency retrieval system, which is a temporary system of modular guide mast, and this will be of very light material, so that these transmission lines will be supported till the original towers are restored. So due to this, in 2 to 3 days, the powers can be restored. Even though this kind of system is available elsewhere in the Western countries, the cost is very huge, and it is not available. Indigenous technology is not available, and every power company, they import this, and they invest a lot of money in that. And towards this, SCRC has developed an indigenous technology, which is very cost effective ERS we have developed, which is suitable for 33 kV to 800 kV transmission line systems. And Salon features, if I see, it is very the planning, transport, execution at site, it's very easy. It's very simple to fabricate and also easy to connect, and easy to construct foundation system, because these all be rested on a foundation system. And it is very compact. You can take in a truck and then put it on the site, and it's very modular and also economically affordable. And based on the different voltage classes, they can be flexible, like this configuration can be modified and then constructed easily, and they are more structurally stable, because these structures have been tested for the design loads, and the prototype test also has been carried out at our tower testing research station. And if I have to say, the cost is around 40% less compared to the imported ERS system. And number of patents have been filed on this. And also, the technology has been licensed to Advait, and they have got number of inquiries from the power companies. And this is one major thing which is very much needed for the country. And the second one is on the mass housing. As we all know, like the construction demand for high mass housing is required, and towards that we need a quality construction as well as speedy construction. And keeping in this mind, SGRC has come out with a precast lightweight wall and roof panels, which can be assembled and for mass housing. And these are very durable, energy efficient, and most of them are precast components, and also light in weight. These components are very light in weight. Uh, Thermal conductivity is also very good, because this has got a EPS panel, expanded polystyrene, in between two layers of mortars, which are connected through an innovative system. So this has got a very good thermal insulation, and it has got excellent shock absorbing capacity, and it can be cast using concrete. Because of that, it is a faster casting is also there, and better quality control, because this can be made in the factories. And as you see in this figure, it is transported to the trucks, assembled at the site. Right from the foundation system to the entire structure can be assembled. And we have tested all kinds of tests in the seismic qualification, as well as lateral loading, and the bending, axial loading. Everything has been tested. This structure has been tested, And we have in-house demo building, and also at CLR we have used this and then constructed a school building. And the bottom one, this figure in the right side, shows a colony where this technology has been used for the Hudhud cyclone victims. And the cost is also very less, 10 to 15% less compared to the conventional precast construction. And this has been transferred to Mrs. Level 9 BIS India Private Limited. And the other one is only textile reinforced concrete packing technology. This is a very innovative technology where the industrial textiles are used, and this is also a green and innovative construction practice without using molds. And it is a single technology where we can use it for multiple products. The TRC panels can be easily folded into different shapes and forms, and also they gain 40 to 50% gain in prefabrication time, because it is a traditional mold-based concrete casting takes more time, and also labor effort is also less because these are very thin things, and also there is CO2 emission is also less. And if you see these various, we also have a prototyping technology. This whole thing can be used for creating different types of panels. One is, as you see in the left hand side, these are like sheets which can be used for roofing, and the canal linings also, they can it can be taken and put in the place, and also tiles, and for the structural strengthening also it can be used. And this as a particular technology has been used in having constructed easy to build a TRC toilet, and this has been implemented in our one of our demo buildings at hospital building at Arakonam. And how this can be done in a mass scale, that also we have thought of, and two models we are proposing. One is we can do a precasting at site and take them with unskilled labor. You can use it with proper supervision and can be assembled at site. The other one is the entire thing can be kept in a truck, and then it can be taken to the site, and there itself we can start the precast. We can get these products out of the trucks and then implement them at the site. These are the two models which we are proposing. And also using this, again, this textile reinforced concrete, we have also developed a precast boundary wall panels. Normally we would have seen boundary walls. This boundary wall is relatively 85% reduction in weight is there, and also material cost is also reduction in material cost, and it is a non-corrosive reinforcement. Normally the reinforcement will be of steel, but in here textile is being used, industrial textile, and all these make them a promising potential product for to be implemented. And this has been transferred to LNG, and this is the which demo. As you can see, only 2 people are required to take them and then lay it on the site. And this also has been tested. All these products have been tested with our in-house facilities, like for different various loading conditions, after which we transfer the technology. So once we ensure that all the required criteria is satisfied, then we try to transfer these technologies to the industrial partners, and they try to implement in field. And using the same technology, right now we are also creating textile reinforced U drains for stormwater infrastructure, and cost effectiveness is around 30 to 50%. The next technology which will be of use to the people directly, for society, cost-effective water tank with a flowable cement motor and thin concrete precast panels. So we have modified the cement motor without compromising its strength, and also the demand on the requirement of high type skilled masons, and also the cost is substantially less compared to the commercially available product. As we can see, the left-hand side, we have got a water tank cast using flowable cement mortar. The other one with precast concrete panels. These panels, individual panels are there, and they can be assembled at site to create the tanks. So this, if you see the assembled precast water tank is being lifted. This is capacity is around 10,000 liters, and it can also be scalable up to 20,000 liters. And if I see what is the cost, it is around for 10,000 liters, it is around 3,500, and it has been transferred to Lakshmi Srinivas Engineers, Hyderabad, and they are in the process of commercializing this. And this is very easy to build, durable as well as safe for storing water. Less weight compared to RCC and masonry tanks, and viable alternative to plastic tanks. And because of this, it addresses the sustainability issue, and high market potential is there for this product. And towards when this COVID was there was a urging need for the number of hospital was that came into mind, and we thought make sure immediately we need a hospital rooms where they can be used for isolation or something. So for that, it is we came into this kind of modular foldable unit where it can accommodate 2 to 3 beds, and it can be erected within half an hour with 1 ton capacity, and everything is inbuilt, and no skilled labor is required, and also foundation is also not required. So it's least time consuming. And if I see 10,250 per square meter with minimum facility, that is the cost. And because of the immediate need, it is very much suitable for this. And not only for the hospitals, it can be used for temporary shelters or construction site accommodation, and strategic need where inaccessible area we can go in this. So this is how it is being done. This initial position, in the folded position, this structure looks like this, and then it can be erected using the crane. And after opening it, the front panel and the door panels are open, and the structure is ready. If you see the inner view also, you can see it is very much ready, like you can use it directly. And all lighting and other things are it is inbuilt in that. And this technology has been transferred to L&T Mumbai and Pressmac Infrastructure Private Limited, Chennai. And another toilet core unit using precast concrete segmental panels. So this is again a cost-effective, durable, ecologically safe toilets, and thin precast concrete segmental panels are used in this. And it can be with the tanks, septic tanks also can be constructed, and in 3 hours time you can assemble the panels, and then erection of toilets can be done. And also it's very much suitable for mass production through industrialization. These are different people to whom we have transferred the technologies. I think 3 people have taken up this technology, and we have implemented in our CLRI campus also. We have implemented this. Now I think 6 such units have been implemented. And the another technology is eco-friendly geopolymer block technology. So it has got a very low carbon footprint, and also it can go towards complete replacement of Portland cement, which causes CO2 emission. And also we can use the industrial wastes, which we have to again find a way to dispose it of. That can also be used in this. 2 way it is beneficial. Once we are using the industrial waste, as well as reducing its impact on the environment. And if you see, there is a zero water for curing. Again, water for curing is not required. Ambient air curing is sufficient, and lower embodied energy. So embodied energy is low, and it achieves mechanical strength in a very short time, and it has got a very good durability properties. So it is in effect, it's environment friendly and sustainable. So also it has got a better life cycle cost compared to conventional blocks. And this initially we have done the lab scale production, which has been transferred to a number of I think 4 industries, and they have commercialized, And we have also demonstrated the factory scale production of geopolymer. And this has been also used for construction of additional classrooms in Kendriya Vidyalaya CLRA campus. And this is a problem addressed through this is one is we are reducing the carbon footprint and also less water consumption and disposal of industrial wastes. And it can be used in buildings, landscaping, container yards, footpaths. There are a lot of applications of this geopolymer technology. So these are the readily available technology, and many of them have been transferred with these pipeline, which is ready to be. Still some more effort is required, and these are technologies which are in pipeline. One is on the conductive cement composite as embedded sensor. So in case of sensors, we import a lot of sensors for the structural health monitoring, and they have a differential behavior, like we paste it on the concrete or on the steel. This in the concrete, if you take this kind of conductive cement composite, it can be embedded in the concrete itself, and it is very much innovative, and the outcome is also very good. So we are in the process of converting it into technology. The other one is a similar kind of thing, where cement composite sensor, which is used for corrosion monitoring in structures. And also the third one is on the structural health monitoring using acoustic emission sensing. This also we'll have a piezoelectric patch which will be used to do this. And also we have got innovative embedded reinforced concrete double shear connector, which helps us. It's a different form of a double connector used in steel concrete composite construction. And also wall panels for housing, where we can use the waste materials. The other one is on laced steel concrete composite, which has got a very huge potential on suddenly applied loads such as blast and impact, and which can also be used for other explored for other applications. I'll be just giving a glimpse of all these things. One is on the laced steel concrete composite. If I say this is patented, a US patent and Indian patent is available, which has got a very huge deformability, like a high ductility and rotational capacity is there, which is required for absorbing the energy. And it is effective use of minimum, like material effectiveness is very much in this, and it is also possible for rapid installation, because these can be made factory and assembled at site, and better quality control because of that. And if I say these individual units can be assembled, and we have done laboratory scale testing to ensure that that the continuity is there and it transfers the load properly to this for which it is intended. And we are also in the process of we have done the numerical studies, but we want to also explore it for the actual blast loads that we are proposing. Once that is ready, then we can transfer this to the clients. And the other one is on the low cost, as I was telling, the integrated acoustic emission technique, which is one of the most effective technique, and it's also at early stage of damage or leakage initiation inside the structure. Under the service load condition itself, we can use the sensors.
Madam,
Yeah,
madam, please.
I will be taking another 2-3 minutes. That's all.
Please, madam. 3 more speakers, please.
Yeah. Then there is a multi-scale engineered strain-hardened cement composite, which is used for structural upgradation, which enhances the structural thing. These are all in the pipeline, so we'll be developing these technologies into convert them into technology. And the other one is on a foam concrete, which is of a lightweight material, which can be used for partition walls, and it has got low density and high fire resistant properties are there, and it is also a cost effective product. And brick mason triplet shear tester, which is required to determine the parameters associated with the shear strength of the brick masonry. This has got a unique property. It is significantly less, and also we are having an efficient beam to column connection for cold form steel frames. And these are other two things where embedded cement composite as embedded sensors. which is helpful in the structural health monitoring. So I would like to conclude with the Thirukural, Arumai Udaithentra Asavami Vendum, Perumai Muyarchi Tharum, which means that you should not listen to the feeble mind that says that you cannot do it, but the accomplishment you achieve by completing the task should give you all the energy to do it. So listen to that mind. With that, I thank the organizers for giving me this opportunity, and also I acknowledge the business development division and the scientists and that team for the presentation. Thank you, sir.
Thank you, madam. Thank you very much for the elaborate presentation on the array of technologies available with the CSIR Madras complex. I'm sure that interested people will contact you, and we wish you all the best for developing the technologies which are in the pipeline and to take it to the logical conclusion. And we all know the vital role played by CSIR laboratories for Atmanirbharatha, the self-reliant India. Thank you very much, madam, for spending your time with us. Thank you. Now it is my pleasant duty to invite one of the tallest scientist we have, I can say, right now with us, Dr. Pradeep. Pradeep is an institute professor at IIT Madras. He is a Deepak Parekh Institute Chair Professor, and he has done his studies at University of Calicut and Indian Institute of Science and UC Berkeley and Purdue University. Research interests are molecular and nanoscale materials, and he develops instrumentation for such studies. He is an author of over 525 scientific papers in journals and inventor of 125 patents, patent applications. He has, in addition to his work on advanced materials, he is involved in the development of affordable technologies for drinking water purification, and some of them have been commercialized. Pesticide removal technology is estimated to have reached about 10 million people. Along with his associates, he has incubated 7 companies and 3 of them have production units. His arsenic removal technology, approved for national implementation, is delivering arsenic-free water to about 2 million people every day. He is the recipient of several awards, including Shanti Swarup Patnagar Award, prize of 2008, World Academy of Sciences prize in 2018, Padma Shri in 2020, and the list goes on. He is a fellow of all the Science and Engineering Academies of India, Royal Society of Chemistry, the American Association of Advancement of Science, etc. He has written several books and part of over 10 scientific journals, and is an associate editor of ACS Sustainable Chemistry and Engineering, authored popular science books in Malayalam, and is a recipient of Kerala Sahitya Academy Award for Knowledge Literature. He has received Lifetime Achievement Award, Research Award of IIT Madras, and Distinguished Alumnus Award from the Indian Institute of Science. We are very happy to have you, sir. Thank you very much for being with us today. Please, waiting for your answer.
Thank you, Professor Dr. Ramasamy, for this kind introduction. And let me get on to this. Well, let me thank all the speakers for presenting Tamil Nadu's might in technology transpiration for Atmanirbhar Bharat. I will take exactly 15 minutes and then conclude this presentation. I thought, well, the topic itself was given to me by Professor Ramasamy, that water technology, particularly for drinking water, and Atmanirbharatha. Technologies that we talk about are essentially everything came from our laboratory. IIT Madras is a much larger system. A lot of things are happening here, so you should take this in the larger context. I will not be in a position to present all of those giant initiatives IIT Madras is doing, the nation is doing in this very limited time. I will focus essentially upon my things. It's about what? And it has to be looked at Atmanirbharatha in the larger context of all those Tamil Nadu is doing. Look at our ecosystem. Every river in our country is polluted. That's a shocker. In fact, everything that we have produced chemically, that big chemical diversity that we have, everything ends up in water, as everyone knows. But it is there in our water bodies. And all of those that I have listed here, they can all be found in our waters, far beyond the concentrations that we wish to have. 50% of our microbial diversity is lost forever in our water bodies. And that's again a big shocker. And we monitor several rivers across the country. Indian agriculture is being threatened in very many ways because of groundwater depletion, and a lot of technologies have come to address water problems, especially the drinking water problems. And we have been fortunate to address these with materials. Now, I have been saying for a long time that affordable clean water is also a problem of advanced materials. And the subject area today, we call it Aqua Nanotechnology. And there are several papers and books and all that written in this area, largely around new adsorbents, new sensors, new catalysts, new phenomena, new devices. And I will spend a little bit of time on maybe one or two things today and one or two technologies today. So ultimately, what is that we can do? We have shown that with materials that we have developed in the laboratory, affordable materials we have developed in the laboratory, green materials that we have developed in the laboratory, some of the mundane problems of humanity, especially in the country, can be solved. Arsenic has been a problem, and we continue to suffer from this. We know about this problem for the past nearly 108 years in our water bodies. Although in India, this is known for the past nearly 40 years or so intensely, but globally, this problem is known to exist. The problem, how can you address this? With materials. And we showed that the materials we have developed in the laboratory with 1 milligram, 2 milligram scale and studied the science of it, patented, etc., have now gone on to several tons, several tens of tons, and a few hundred tons. So that's the scale at which we are in a position to take technologies forward. I'll give you a brief glimpse into that. Look at this particular hand pump. This is in Nadia district of West Bengal. And the cement platform, if you are seeing, is red in color. That is because of red oxide, because of the iron present in this water. Now, if you go to that particular region, and if there is iron present in water, there is a possibility that arsenic is present also, which is colorless. But in this particular water, arsenic is present 10 times more than the permissible limits. Now, you can put a small filter there. And this is what we have done. And you get water. And this water conforms to US EPA norms or WHO norms. There is no pressure drop that is there, and the water comes out, without any loss, and there is no head pressure loss, and the boy is in a position to pump this water in the same way that he has been pumping regular water. This water is 1,000 liters of water every day. This is what the product is, but it can go to many, many different products and different scales. And it works, as far as this particular field is concerned, it works for about 3 years, and then the material has to be changed. The basis of this is to create nanoscale materials. This is a small particle of about 3 nanometers in diameter with a specific structure, creating surface groups wherein you can absorb both arsenite ion and arsenate ion at the same rate, essentially with similar kinetics. Now, with this, you can model how much of materials capacity is there, etc. You can also do experiments in the laboratory, a small quantity of this material with input water concentration having 100 parts per billion of arsenite and 100 parts per billion of arsenate, is 200 parts per billion of arsenic together. And you get 2 parts per billion of arsenic when it passes through. This amount of material, about 18 grams or so, it will remove arsenic from 1,200 liters of water. So you essentially get clean water. So what it means is that it's a great product, and we took it to field, test it. Unfortunately, there was a district collector who allowed us to test it in arsenic-affected soil, and we called it Amrit. And we called it anion and metal removal by Indian technology. There are a large number of metals that you can remove, large number of anions that we can remove. So we took one particular district called Murshidabad district, and this is an expanded view of that Murshidabad district. 100 locations we chose across Murshidabad and tested this technology. And we scaled it up to larger scales. So this is a traditional treatment plant which works something like 200,000 liters per day. So that is 20 meter cube per hour. If you run it for 10 hours, that is 200 meter cube. That is 200,000 liters. And that has traditionally, this is what you use. And this is spread over several tens of cents, about 40 cents of land area in this particular case. But because these materials are highly efficient and very, very small quantities of materials have to be used, same plant capacity, you can reduce it to 3 cents of land area. This kind of towers get reduced to something like this. And this was the test that we conducted with arsenic concentration of 168 parts per billion, 16 times above the limits, and you get 2 parts per billion output. The same kind of, roughly the same kind of capacity, 180,000 liters per day. You can now go on. So now I am sort of taking about 10 years of work into, well, in that gap. You put it in the field. So this is just a few days ago, I got this picture from one of the installations. Now you see this plant, and it is, water is supplied to about 2,500 people. From this plant, and this is another plant supplying water, and everything is now 10 years of warranty, and water is supplied with monitoring, and you will see that in the course of this lecture. So price of this is about 2.1 paisa per liter with all costs, materials cost, all the capital cost, all the operator cost, electricity cost, all of them combined together. We say this is the cost of water that is applied. Now, such a water treatment plant can also be monitored, and that can be geotagged, and that can be put across in different places. So finally, this is an absorption technology. It doesn't require energy, right? If you have water is above, water will flow through. It is an absorption technology. Now, obviously, the materials will get saturated. So there is a waste. So how do you manage this waste? And we worked with the state government, and arsenic is an element, you can't break it. If it is a pesticide, you can break it. If something else, you can do photocatalysis. But when it comes to arsenic, you can't do it. With uranium, you cannot do it. With fluoride, you cannot do it. With chromium, you cannot do it. So what do? So you, of course, create materials which will not release arsenic or fluoranium or chromium or anything into water. So for that, the material has to conform to toxicity characteristic leaching procedure. We established that, and finally, let's say, so this is not leaching material into the field. However, you have to contain that material. So you have to have safe disposal protocols developed with the state government. We implement that. So I'll show you a brief movie of this 2 minutes. So that's the water is being supplied to that village from this plant. So each one of these units are monitored remotely, and you get the data on your mobile. And if there is a problem, the technician is alerted, the plant operator is alerted, the state engineers are alerted, the state headquarters will have such a display unit to look at this. So this is about Punjab. There are several such installations that are going on now. In the state of Punjab, we have 200 installations, but you can also have across the country now, there are about 1,400 installations looking at different contaminants. Each one of these is typically supplying water to about 1,500 to 2,500 people. So that's the kind of scale at which this has gone on. If there is contaminant now, there is a materials-based technology, affordable technology, green technology, which can remove these contaminants, and it can be monitored remotely. But if there is no water, what do? You can have water harvesting as one of the methods that we have developed using nanostructures which are created on these surfaces with higher condensation efficiency. So you produce from 35 liters per day units to about 200 liters per day units. In comparison to the previous technology, the water produced is, of course, much more expensive. In this particular case, this is an active technology. Active meaning you have to invest power into this. The other way is that, let us say, if there is seawater intrusion and there is salinity, is there an alternate technology other than reverse osmosis? We have capacitive desalination, which is based on electrical potential applied to electrodes, and you electroabsorb ions, and we have a company based on that. And this company is supplying clean water products across the country, especially in the coastal areas, including in Tamil Nadu. Units such as these, which are run on electricity, solar electricity most of the time. And key point about this is that the reject is 18% in comparison to 55% or 60% in the case of reverse osmosis. But all these technologies require advanced tools to monitor, and many of them are not available. We are developing several sensors. For example, sensors as small as these are now available to do spectroscopy. This is not from ours, but this is something that is available. But is it possible to develop water quality sensors using such spectroscopy? We develop such sensors so that water quality can be monitored in a non-contact mode. Now, if you develop such sensors, what is the outcome finally? This can be used across the country, and this is one such installation. It's not one installation, one per specific region. There are 13 villages we are monitoring, and each one of these villages is now water quality is monitored every minute, and this data are available. Right now, this is not available to public. This is available to the government. So where is this going to? This is going to a hydroinformatics, wherein the nation as a whole, water quality, water quantity, water-related contaminants, diseases, and many others are monitored. As a result, this becomes big data analytics. To build all of these water technologies, we have created a new center. I have been in a position to create these activities at IIT Madras, but for Tamil Nadu, for the world at large, we have created a new center where anybody can come and innovate and build a water technology for future as well as for today. So this is called the International Center for Clean Water. This is at the IIT Madras Research Park. Anyone in this audience and others and your collaborators and colleagues are welcome to come, and this has been possible because of a wonderful team of researchers, and many of our students have incubated companies, including BTech students of IIT Madras who have other job opportunities, but they decided to stay with water. And there are a large number of people whom I should thank for taking the science forward. Thank you very much.
Thank you, sir, for your crisp presentation, but an important one. Thank you very much for being part of this meeting in spite of your busy schedule. Thank you, sir. Now it is a pleasure to invite Dr. Sajid Hussain Inayat, Chief Operating Officer, Tamil Nadu Water Investment Company Limited. Dr. Sajid Hussain has over 29 years of experience in industrial wastewater engineering. He is presently the Chief Operating Officer of Tamil Nadu Water Investment Company, responsible for operations and the water reuse business. He has played a key role in the revival of Tirupur dye cluster through development and implementation of a unique brine reuse technology for achieving zero liquid discharge norms for textile dyeing effluents, also winning of several international awards from UK and other USA and other countries. He has developed ZLD technology for pulp and paper and leather industries also. He has been a consultant to many national and international agencies like UNIDO and other agencies, World Bank, etc., where his work focuses on recovery of and reuses of resources from water. It is my pleasure duty to invite Dr. Sajid Hussain Inayat. Over to you, sir. Dr. Hussain?
Sorry, I think you can hear me? You can see the presentation?
Yes, sir. Please
Okay.
go ahead.
Yeah, so let me quickly run through my presentation. Thanks for the invitation. Happy to be here. Let me quickly explain what I'm trying to do. Okay. See, we are all aware that many of these polluting industries, like textile dyeing or leather industry, pulp and paper, pharmaceutical, chemical industries, most of these industries have moved out from the developed countries like US and Europe and come to India and China, basically because of the labor costs and pollution costs. And if we don't address these pollution costs, these industries may again move to third world countries. Unfortunately for us in India, with a large population, other than agriculture, manufacturing is a very important activity for job creation. So we need to ensure that these pollution issues are addressed and we keep the manufacturing jobs here in India. Otherwise, there is already a trend where many of these polluting industries are shifting to countries like in Africa. And another thing is that necessity is the mother of invention, as they say. And this technology was developed because of a court order where the court said the industry should close down if they cannot discharge anything into the river Noyal in Tirupur. And therefore, this technology was developed. Typically, you do R&D and then you implement technology. But here it was a full-scale kind of an implementation, and R&D went along the way. Just to briefly tell you the story behind the technology, I'll just put a video.
Video has not come yet.
Textile dyeing units in Tirupur are an important component of the entire chain in the manufacture of garments. Tirupur, also known as the knitwear capital and as Dollar City, contributes to $2.25 billion and employs over 600,000 people in the textile industry. The discharge of untreated wastewater from the dyeing units into the river Noyal led to the gradual degradation of the river and polluted the groundwater as well. The local farmers petitioned the courts against the pollution caused by the industry, which ordered the industry to implement zero liquid discharge systems, or phase closure, in 2006. The ZLD project was implemented by Tamil Nadu Water Investment Company Limited, TWIC, at a cost of 4,210 million rupees for a combined capacity of 53 MLD for 9 common effluent treatment plants, catering to about 244 dyeing units in the industrial town of Tirupur. Faced with the challenge and lack of technology and experience in ZLD worldwide, the project implementation ran into severe problems, particularly with thermal evaporation of reverse osmosis reject brine, leading to closure of all the dyeing units in Tirupur under the court orders in 2011. Faced with this daunting task under adverse circumstances of court closure and lack of faith on viability of technology for zero liquid discharge, TWIC, in close cooperation with the industry and support of the state government, developed and implemented a unique treated brine reuse technology at an additional cost of 1,500 million rupees for reuse of over 90% of the sodium sulfate salt, along with reuse of 98% of recovered water by a cluster of dyeing units connected to a central wastewater treatment facility. Underground sewer network for collection of wastewater. equalization tank, biological oxidation tanks, clarifier, tertiary filtration system comprising of quartz filters, decolorant resins filters and softener filters, reverse osmosis system, recovered water distribution system, mechanical vapor recompression MVR type evaporators, brine treatment system, multiple effect evaporator and adiabatic chiller, online monitoring with SCADA, this technology not only demonstrates high recovery of water, but also recovery of salts for reuse within the dyeing industry, thereby moving towards zero waste discharge and not just zero liquid discharge. The recovery of water and salt as liquid brine and Glauber's salt makes it commercially viable and sustainable. Global Water Intelligence UK have recognized the Tirupur ZLD project implemented by TWIC for the prestigious Global Water Awards 2014 as highly commended under the Industrial Water Project of the Year category, and has also termed it as a phoenix rising from the ashes of an environmental catastrophe. This ZLD project of TWIC has also been recognized by Water Reuse Association USA as a significant contributor to the community, choosing it as the Industrial Project of the Year 2014. The implementation of ZLD in the CETPs has resulted in stoppage of discharge of dyeing effluents into the river. The Noyal River and its dependents can now look up to a better future.
That was a small video just to tell you the story behind the technology development. But since then, a lot of more challenges have been faced by the industry. We developed the ZLD technology and made the industry reopen. The exports have grown from 12,000 crores at that time when it was close to 25,000, 26,000 crores. And today the turnover is around 40,000 crores and most of it is all exports. So it's a great achievement, but still there are a lot of challenges. The challenges are like the high capital cost of ZLD, whereas a typical conventional treatment plant for a common effluent treatment plant would cost about 2 to 4 crores. A ZLD plant costs about 16 to 22 crores. So it's very expensive. And the operating costs are also very high, 200 to 400 rupees per kiloliter, which impacts about 12 to 15% on the cost of the dyeing fabric, dyed fabric. On the finished product, it is 1%, but the intermediate product, it is about 12 to 15%. So it's very high in terms of this. While we recover 95 to 98% of the water and 20 to 30, 70 to 80% of the salt, there's still some 20 to 30% of the salt, which is a mixed waste salt and is a disposal challenge. The power consumption, that's a constant criticism of ZLD, the high energy consumption by ZLD systems, typically like 28 kilowatt hour per cubic meter, both in terms of electrical power and steam. And this contributes to about 50% of the operation maintenance costs. So the sustainability of such a high energy guzzling system is also a big challenge. And when ZLD is being done in Tamil Nadu, where we are self-reliant in developing this technology, when other states are not implementing it or other countries worldwide are yet to implement ZLD, our businesses become non-competitive. So how do you make them competitive is another challenge. So one of the biggest challenges, as I mentioned, the evaporators, they are energy guzzling. They take about 400 to 600 rupees per kiloliter in terms of operating cost. And they are a lot of scaling and corrosion because it handles salt from the wastewater. And there is a lot of frequent downtime also because of maintenance activities. So we came up with this brine reuse technology as explained in the video, where instead of trying to crystallize the salt, we use liquid brine that is concentrated from the reverse osmosis plant, treated, concentrated to the required concentration, and then supplying back to the industry, and they use it for dyeing of the fabric. So this is being done for last 9 years now. So this is a very successful technology. Another thing that we looked at is how to avoid totally the evaporation system by increasing the recoveries in the reverse osmosis system. So we modified the existing reverse osmosis plants. We came up with additional reverse osmosis system, 5 grams per liter of brine concentration, thereby reducing the volume required for evaporation. Another thing that we developed was the ultra high pressure RO or high pressure disc type RO. This again, we worked with the membrane manufacturers, and because for wastewater going at such high concentrations entails a lot of fouling of the membrane, requirement of high pressure, and operating is also a big challenge. So we developed a lot of pilot for this, and then they upscaled, and now at least 3 or 4 of the CETPs have implemented this high pressure reverse osmosis system, where you can go up to 110 grams per liter of brine concentration. So again, we further reduce the volume of water that goes into the evaporator. And we have reduced the operating cost by replacing this evaporator, mechanical vapor recompression type evaporator. From 538 rupees, now it has come down to 91 rupees with this ultra high pressure reverse osmosis system. Also, the power consumption has come down from something like 30 to 35 kilowatt hour per cubic meter to 3.5 to 4 kilowatt hour per cubic meter with no steam consumption for this particular stage. The other issue is that I said 70 to 80% of the salt is recovered as sodium sulfate, but you still have mixed waste salt containing both sodium sulfate, chloride, and calcium salts, which is a mixed waste salt and is a hazardous waste as per the Hazardous Waste Management Act and requires disposal. Today, presently, about 60,000 tons of salt is in Tirupur, is being stored, and this is a disposal hazard because there is no solution for it. And increasingly, the pressure from the pollution control board to find a solution. We came up with 2 solutions. One, we worked with the Central Salt Marine Research Institute and came up with the selective salt crystallization technique and implemented one of the CTP called Chinnakarai CTP. Another technology we developed was nanofiltration, low pressure nanofiltration systems for separation of sodium chloride and sodium sulfate salts. So this is the CSMRI technology where selective crystallization that we generate sodium sulfate and also sodium chloride. Both is generated. This has been running for now 4 or 5 years now, and this is very successful technology. We also come up with this membranes based on nanofiltration. We have worked with several membrane manufacturers, including some in India, and come up with this specialized nanofiltration membrane where you have to separate sodium chloride and sodium sulfate. High purity you have to get. We are producing now industrial grade grade 2 quality of sodium chloride and sodium sulfate, 98% purity. And this is not only used by the dyeing industry, but we also use it in the textile industry. Also in other industries, they can be sold. So just to summarize, from conventional ZLE, which you saw in the video, where we were operating costs of about 350 rupees per cubic meter, with the nanofiltration system, you can come down to 215 rupees per cubic meter. Also, the power consumption from 12 kilowatt, it comes down to about 8 kilowatt. So it's a considerable reduction in cost. Another thing that we worked on was, okay, now that we are avoiding generation of waste salt by putting up nanofiltration or selective salt crystallization technique, the accumulated salt also has to be disposed of. So we have come up with a pilot plant, which is with the support of Tamil Nadu Pollution Control Board and the Central Pollution Control Board. Under the ECF, we are going to implement this pilot. We have developed this technology, and we'll be demonstrating how to recover salts from the mixed waste salt, which is accumulated in the Tirupur cluster. And I mean, if we do this, then disposal of salt cost comes down. We can generate additional revenue also because these additional salts can be sold in the open market to various industries. And these ZLD CTPs will not only be a water factory, but also will be a salt factory. We have also come up with a membrane distillation where we can use solar thermal energy. So that the energy consumption, I mean energy footprint comes down considerably and it becomes more sustainable, more green. This membrane distillation technology, we have done a piloting and we are going to go in for a one CETP for implementing this in Erode. And this will ensure that the carbon footprint comes down considerably, or the operating cost also comes down considerably. Thank you. I might have hurried, but because of shortage of time, I try to finish as quickly as possible.
Thank you, sir. Thank you very much indeed for your nice presentation on the effort taken for the common effluent treatment plant and the problems associated. It's heartening to note that you are solving the problems as and when the progress is happening. Whatever problems you are encountering, you are coming out with suitable solutions. We wish you all the best for your future endeavors also. Thank you very much for your presence today. Thank you.
Thank you, sir. Thank you very much.
It is my duty to invite Dr. R. Kumaravelu, Professor, Department of Computer Science and Engineering, P.T. Lee Tegalvaraya, Nayakar College of Engineering Technology. Dr. Kumaravelu is a recipient, received a diploma in Computer Science and Engineering from Central Polytechnic, Germany during 1990 to 93. Bachelor degree in Computer Science and Engineering from Madras University during 95 to 98. Master degree in Anna University during 2006 to 8. During the year 2014, completed PhD Embedded System degree at Anna University. Dr. Kumaravelu worked in Kalasalingam University, VIT University, and Anna University. His field of interest are network security, image processing, embedded system, weaving technology, product development. He received a design certificate and patent from Intellectual Property of India. Currently, he is working as professor in P.T. Tengalvaraya, Nayakar College of Engineering Technology, Kanjipuram. He has more than 18 years experience, including teaching and industry. He completed 1.5 crore funded projects with the support of Department of Science and Technology, Department of Scientific and Industrial Research, and also the Tamil Nadu State Council for Science and Technology. We are very happy to have you, sir, and we are eagerly waiting for your address on the development and demonstration of electronic jacquard for the handler weaver. Over to you, sir.
Sir, am I audible?
Yes, sir.
Good afternoon, sir. Thanks for having this opportunity to share my experience among you. And for the past 2 decades, I am in the field of handloom-based product development. Through this Department of Science and Technology and the State Council, I got an opportunity to develop an electronic cordless jacquard for handloom weaving. So actually, I'm going to narrate very few things, but I'm going to show you my videos, so what I developed. So basically, these are things that I'm planning to illustrate. Actually, there were 2 objectives in my research. One is to reduce the laborious work of the handloom weavers, and the second one is to reduce the recurring cost involved in preparing the woven designs. Why? Because in saree fabric manufacturing, a weaver has to exert minimum of 20 to 25 kgs of weight for each time. So like that, 2,000 to 3,000 times per day they have to perform their job. It is highly laborious one because their hip joints and shoulder pains, they used to get it. But with the help of this research, that work has been nullified. And second thing is, they have to incorporate jacquard card systems for bringing the designs on the woven saree. So that is going to be nullified with the help of this work actually. The first thing, woven design, it uses punch card system. So all of us know that Joseph Mary Jacquard, he was a weaver and also he was a businessman. He introduced punch card system for his weaving process. Later on, this technology was adapted by Charles Babbage in his modern digital computer programming. So now we are using the modern digital computer to restructure the jacquard system. It is like a circle because our computer system has been started from punched card. Now we are again using the computer for punch card restructuring. So actually the punch card will be like this. So these holes represents wherever the threads has to be lifted up and down. Basically, it's a pure digital logic. because the threads, it has to move either up or down. Wherever it has to move up, that should have holes in that appropriate place. Wherever there are no holes, in those places, the threads will not be moving up, I mean rising up. So in this way, we have to categorize the design actually. So the stored, it is like a stored pattern. So here our design data will be available. So this will control the mechanical system. Now with the help of this device, we are going to replace this punch record system. Instead of that, we are going to use a digital memory storage unit where we are going to have the woven design data. Thereby, it is going to control the loom actually. So let us see this video. This is a technology transfer video, and this is a conventional loom with a punch record system, and this is a modern loom with electronic jacquard. So now weaver is inserting and also he is exerting. So each time he has to exert minimum 20 to 25 kgs of weight. Whereas now this is an electronic jacquard system. Now he is not exerting because he is operating. So the digital system will be controlling this loom. So it is highly sophisticated environment. This is a manual one. It is highly cumbersome environment. This is a digital one. It's user could. So these are all lingos actually. It is moving up and down. Now with the help of this memory card, we are keeping the design. So this upper part is known as jacquard system actually, mechanical jacquard system. During the rainy season, these cars will not be rolling properly because since it is made up of paper particle, so there are many issues during the rainy season. But nowadays we have this electronic method of working way, so that will not create any issues during the rainy season. Actually, in my research and product development, I have devised two methods, I mean two techniques. One is by using stepper motor, another one is by using a solenoid one. Whereas for the stepper motor, actually I used to purchase from the other countries only, Japan only. But now I'm using a solenoid. So instead of stepper motor, I'm using the solenoid method. So that is low cost one, and also it is completely indigenous one. So let us see this how I am testing this solenoid working. In my laboratory testing, I used to assemble the entire thing and continuously based on the various design pattern, how the solenoids are working, how much power it is consuming, everything I will be calculating. So once assembling everything is over, I will have integration testing. Actually, this part is a master where it is having all the design data using RS485 serial interface bus. It goes to this part. This is a client part, and this will be controlling this electromechanical machine. It's full of solenoids. Again, once the mechanical parts have been ready, so we used to check without the electronics, only mechanical part, how it is working. And this is another one. This is a guide block preparation.
Start.
அதை வந்து விந்தே போட்டாதி லைன் போட்ட வின்றாத அத்தாஸ் லோகோ டிசைன் தவி டிசைன் தவி வினராத
using the new technology.
இதாங்க ஆட்டோமொபைல் சாதாரண ஜக்காடமோ அட்ட தவி வினானோ இது எலக்ட்ரானிக் ஜக்காட தரவும் மிசி அட்ட வினா
only installing the no other activities he is performing.
Start.
அதை வந்து விந்தே போட்டாதி லைன் போட்ட வின்றாத அத்தாஸ் லோகோ டிசைன் தவி வினராத இதாங்க அட்ட தவி வினானோ இது எலக்ட்ரானிக் ஜக்காட தரவும் மிசி அட்ட நின்னா லோகோசி மெமரி கார்டு மாதிரி டிசைன் அவி அங்க பதிவு தெரிஞ்சிடணும்.
So there is no
memory card avi
punch card
the box
system.
mein connect kiya sundhi
And electronically it is
design
electrically we call it as threading. So the weaver is operating in a highly comfortable mode, and this is a completely indigenous product.
handle audio adu mein mati button play this place at adu or tenga design avada మేము అంటే పంట అన్న తక్కుని ఇది తరని ఒక టైం తీరాలి ఇంత టైం కొడదాను సో వీళ్ళ ఈసారి ఏం చేస్తే ఇవి 1 మీటర్ అయితే బట్టలు రెండే కాదు 2.5 మీటర్ మళ్ళీ టైం Kita ini rendra panera musa isi. Time ko siap bersih.
So like that, the weaver can work in a comfortable mode up to the length of the fabric. So the design should be automatically generated based on the data available in the memory. Actually, this project was funded by Department of Science and Technology in association with the Tamil Nadu State Council for Science and Technology, and the patent was filed during the year 2013. In the year 2021, the patent was awarded for this project, and recently I got the purchase order from Nagaland Cooperative Society, Women's Weavers Cooperative Society for this product. The products have been parceled there. I'm yet to install and do the required trainings. And in this juncture, I would like to say my sincere thanks to our Department of Science and Technology as well as our Tamil Nadu State Council for Science and Technology, bringing this product successfully and for their encouragement and all the support. Thank you, sir. So thus I'm ending this session.
Thank you, Professor. Thank you very much for your presentation.
Very much. Now I request Mr. Vigyan Prajapati. Sir. Sir, from DST, Vigyan Prajapati is on the webinar, I think. Sir, Vigyan, sir? Okay. Now, I request our Dr. Ramaswamy to give the vote of thanks.
Thank you, sir. Thank you very much. It gives me great pleasure to propose vote of thanks on behalf of Tamil Nadu State Council for Science and Technology in this important virtual meeting. So far, all the councils have conducted virtual meeting on various themes in science and technology. And this particular meeting focused on very important topic, which is the contribution of SNT towards industry and Atmanirbharatha. We would like to wholeheartedly thank Dr. Shankaran, Professor of Eminence and National Networking Consultant in NSCST, Anna University, Chennai, for his effort on the activities at Anna University and National Hub for Healthcare Instrumentation Development. We would like to take on record our sincere thanks to Dr. Sriram, Director, Central Leather Research Institute, Chennai, for his address on the contribution made by CLRA for leather industries, particularly for treatment and management of waste and wastewater. We would like to thank Mr. Shaktivel, General Manager, Tamil Nadu MSME Trade and Investment Promotion Bureau, Chennai, for his excellent presentation on the role played by Trade and Investment Promotion Bureau for the development of industry sector, particularly the MSME. We would like to thank Dr. Pradeep, Institute Professor, Department of Chemistry, IIT Madras, for his address on contribution made by him and his team in IIT Madras in the field of water and drinking water purification. It is relevant here to mention that he has been also awarded by Tamil Nadu by the Tamil Nadu State Council for Science and Technology for as a Tamil Nadu Scientist Awardee. We would like to thank sincerely Dr. Anandavalli, Director, Structural Engineering Research Center, CSIR Madras, for her address on the contribution made by CSIR for the industry sector. It is well known that CSIR laboratories form the backbone for research and development, particularly for industry-related problems in our country. We would like to thank Mr. Sajid Hussain Inayat, Chief Operating Officer, Tamil Nadu Water Investment Company, Chennai, for its presentation on the role played by Tamil Nadu Water Investment Company and the common effluent treatment plant, particularly for textile and wholesale sector. We would like to thank Professor Dr. R. Kumaravelu, Professor of Computer Science Engineering, PT Lee Chengalvaraya Nayakar College of Engineering and Technology, Kanjipuram, for his presentation on the project supported by the Council and Department of Science and Technology on the topic Development and Demonstration of Electronic Jacquard for Handloom Weavers. We would like to thank Dr. Devapriya Datta, Advisor, DST, Dr. Rashmi Sharma, Scientist of DST, Dr. Ravikant Prajapati, Scientist DST, for their support and leadership. We would like to thank all officials, member secretaries, officers, scientific personnel, and others from various state councils of science and technology who have participated in this program. We would like to thank all the participants, particularly the scientists, researchers, faculty, students from various colleges and universities who have participated enthusiastically in this program. We would like to thank our own colleagues, first of all, our own member secretary, Dr. R. Srinivasan, for offering the welcome address and for his support, leadership, encouragement for the successful conduct of this program. I would like to thank all the council staff who have made contribution for the successful conduct of this program. I thank one and all. The next meeting is on August 4th. The theme for that particular meeting is IPR. We would meet on that particular day for another meeting. Thank you very much. Participants can fill up their response form and send it to the council so that you can receive the certificate. Thank you.